So clouds are this multi-billion-dollar industry, and we're now going to hear three talks from really good speakers. Going to tell us a little bit about thoughts about the infrastructure of clouds. So let me introduce here Eiríkur Hrafnsson. He is the CTO of GreenQloud. He's going to tell us a little bit about their company. Eiríkur.
Hello, everybody. I'm actually the CEO and co-founder, but pretty much same job when all of the staff is tech people. So where's actually the clicker or something here? Yeah. All right, I'm going to be talking to you about volcanoes and what they have to do with sustainable cloud computing. Now, I don't know how many here actually know what cloud computing is, so maybe a raise of hands would be good. Like, how many here? Great. The basics of cloud computing is that there are typically considered three types of services in cloud computing. The bottom layer, which services all of the other ones, is infrastructure as a service. And my company, GreenQloud, is an infrastructure as a service company. But on top of that, you have the developers and companies and institutions usually working in platform as a service or software as a service. So just usual examples, platform as a service is something like Google App Engine, which was probably the first platform as a service that was popular. And everybody here probably knows Dropbox, or just Google Apps, Google Mail. And that would be a typical software service application. Now, infrastructure cloud, I usually like to describe it as a self-service buffet. Because simply you are buying and consuming services on a need-to-consume basis. Usually the services are billed in a very specific way. They're billed by the usage, so you're only paying for what you get. And there's no overcommitting. And that's one of the reasons why the economics of cloud computing are so appealing, especially after the economic crash that we've all been through. Now, however, there's a lot of cloud washing going on, and not all clouds are created equal. And that's why I put on my slide that data centers are not cloud, which a lot of people think are clouds. And virtualization alone is definitely not cloud. One of the prerequisites for a cloud, infrastructure cloud, is that it has an API, that you can automate it through programming or scripting. If you don't see that, then it's a false cloud. Now, there are three types of clouds in general. Some say there are four. Public clouds, private clouds, and hybrid, which use both private and public clouds. And there's this new concept now of a community cloud, which actually I think is simply just a private cloud. So last year was the worst ever carbon emissions situation that we've had since the beginning of being measured. And The Guardian says here, worst ever carbon emissions leave climate on the brink. And so what's cloud got to do with it? Well, IT was responsible in 2007 for as much carbon emissions globally as the aviation industry. And if you think about it, in 2007, the first truly popular public compute cloud, which is the Amazon cloud, was barely started. It started in 2006 with the S3 service, which now contains billions and billions of objects. And it seems that the cloud is driving the future need for all data centers. So if you're talking about Facebook or just Amazon or GreenQloud, all of these services, they live in data centers and they are driving the energy need. And because of that, and because cloud is growing approximately 5 times faster than anything else in IT, companies or analysts like McKinsey and Company have said that the emissions from IT or ICT will effectively double in the next 8 years to 4%, which is, I think 4% of global carbon emissions is something that we should be worried about. So, but public compute clouds are super efficient and totally green, right? This is the message we're getting from Microsoft. It's the messages we're getting from pretty much most of the biggest players. So, if we take a look at one of the greenest participants in this industry, Google, you can see that just one of their arms, which is YouTube, is actually putting out a lot of carbon emissions simply by people watching videos. And that's what? That's 4 million, almost 5 million tons a year simply for people watching funny cat videos. That was a reference to my previous lecture, if you missed it, Saving the World from Funny Cats. Anyway, so the good thing about cloud is that it's definitely more efficient than traditional IT. It does indeed reduce the energy footprint of existing infrastructure. If you're migrating from an old system, finally starting to use virtualization through the use of clouds. And pretty much everything is going into a cloud today. Scientific processing, web hosting, you name it, data storage, personal and business. And the good thing about this is that it's consolidating the energy problem to the data centers. So where we can actually tackle the problem in a standardized way, and use best practices. And it's definitely cheaper and much more scalable than traditional IT. So the bad part is that efficiency isn't sustainability. And many people have talked about this and shown this in action. And the latest report from Greenpeace, How Clean is Your Cloud, effectively showed this in numbers. And there you could see that the average use of renewable energy was actually lower than 25% across the industry. And Amazon there being the worst, with only using on the average 13% or 13.5% of renewable energy. So in fact, public clouds are not truly green because they rely on dirty energy. And because of the new economics of cloud computing, that will not be sustainable. Cloud computing are built for efficiency, public compute clouds, which leads to lower prices, which leads to actual more usage and not less. And that's what is called the Jevons paradox. And that's why I believe that we need to power all public compute clouds by renewable energy. But people would ask, so where's an abundance of renewable energy and the infrastructure to support such a public compute cloud? Not a leading question at all. Yeah, so Iceland seems to be the perfect place and the cool place for creating a public compute cloud. And it just so happens that volcanoes are more useful than just for delaying flights. If you remember, nobody remembers this, right? So why not use that to our advantage instead of coal or petroleum or natural gas, which some pundits are saying is a renewable resource. So that's basically what GreenQloud is all about. We are the world's first truly green public compute cloud. We run out of 2 data centers here in Iceland. We're 100% powered by renewable energy. So in Iceland, we have the unique situation that the grid is 100% renewable. It's 30% geothermal, and it's 70% hydro. And what we did when we created this company a couple of years ago, we set out with a mission of having a high-performance cloud. We wanted to make it compatible with the industry, so we actually reversed engineered or made our cloud compatible with the Amazon APIs. So a number of third-party tools already work with it, and applications as well. And we wanted to make it really easy to use, and I think we managed to do that. But more importantly, we also make it completely transparent how much energy users are using, and we automatically calculate the carbon or the avoided carbon footprint for people. And opposite to maybe popular belief, Iceland is actually on the top 5 list of the safest places to use as a data center country. And there are absolutely no legal or privacy issues in Iceland because we are part of the EEA. Now, here's a fun fact. Did you know that we actually saved a lot of emissions, around 40% of emissions, during the volcanic eruption in Iceland in April last year, because of all the cancelled flights? So volcanoes can actually be not so bad for the environment. And opposite to popular belief, volcanoes also are insignificant to CO2 emissions around the world. And there are always active volcanoes all around the world, as you know. And in the picture you can see our data centers. And that's the Eyjafjallajökull second eruption. And as you can see, the prevailing wind direction in Iceland is actually southward bound and southward and eastward bound. So the data centers and pretty much all of Reykjavik were not affected at all by the ash. And that's one of the reasons it's safe to have a data center here. And also that we simply don't build data centers next to volcanoes. That would be stupid. So I'm just going to quickly go through the products, just to tell you what we're doing. But then I'm going to switch to talking about NRENs and how this all fits together. So we have 2 main product lines. One of them is compute power, computing on demand, which I was just talking about. And we also have spot computing, meaning we have a bidding market for unused cycles of compute power, which really can save you a lot of money in terms of if you're measuring it like per hour, it's probably 50% less than the list price of hourly rate. This is our interface. Today it's going to get even simpler. Here you can see the green metrics, or what we call truly green statistics. And here I'm seeing like the estimate for this account for a year, if I would be running the same for a year. But you can always see it live, or live statistics as well, which makes it really useful for if you want to measure the efficiency of software, for example. Then you can just simply run it for a while and you can see the energy use from the panel that we have there. And then again, we have object storage. This is one of the telltales also of false clouds, is that usually they only have the VM operations, just starting up virtual instances and calling that cloud. The good thing about having an object storage system is that it can be easily used to both store massive amounts of data without having to provision any of the storage up front. And you can use it as a delivery platform at the same time. So I don't know if all of you know that, but Dropbox, for example, is built on Amazon S3, which is an object storage which our storage cloud is compatible with. And they actually just started now to build their own infrastructure. So you can build a lot of things on top of object storage and even use it as a database. Looks like that, but actually you can use it for many applications. You could use it from open source stuff like CyberDuck. You can use it from commercial Windows for backup or Windows backup for desktop or server. And just for fun, we created a WordPress plugin to enable WordPress users to actually make part of their WordPress installation sustainable. So we'll offload the static images, no matter where the WordPress instance is deployed, if it's in GreenQloud or anywhere else. We can remove the static files, the images and uploads, put that in Storage Cloud and deliver it from that seamlessly. So you would at least make a bigger part of your WordPress blog sustainable with simply installing a plugin. We have customers now. We're still in beta, which is probably gonna. We hope to end that beta in 1 or 2 months. But we already had a global customer base, and which ranged from SMBs to developers and startups. We have one NREN, which is SURFnet. We're doing some projects with them that the next speaker will tell you about. And we're also working towards kind of merging cloud and HPC. So, for example, internally our infrastructure is hooked together with InfiniBand, 40 gig InfiniBand, rather than 1 gig Ethernet or even 10 gig Ethernet. And some companies are using that, or using the high performance part for their own gain. And it's funny to say that we actually do have the only weather forecasting service in the world running on GreenQloud that doesn't affect the weather. So you figure out how that's happening. Now, so I want to talk about NRENs in the cloud space. And actually, when I was thinking about this topic, like should NRENs be building their own clouds and all that, I got drawn to a previous lecture I had in Berlin that was about telcos. And I was talking to the telcos about how their businesses were in risk of being run over by public compute clouds, with everything like phones going into the IP layer and all of that. And there were some similarities with NRENs, but mostly I think it's on the aspect of, you know, you should do what you do best, and underestimating stuff like building a cloud is a dangerous thing, I think. I would probably say that we underestimated how much effort it was to build a public compute cloud. It's taken us approximately 3 years now to build the software and to populate the data centers with enough gear and to automate the whole thing. So you can get you can get a good start by using open source software, for example. We use open source software. We actually are the biggest contributor to Apache Cloud Stack outside of Citrix. And we made the whole, not the whole, but in collaboration with cloud.com, that later became Apache Cloud Stack, or actually was bought by Citrix. We worked with them with the compatibility layer with the Amazon APIs. So you can get a little bit ahead with the open source software, and I definitely recommend Apache Cloud Stack or OpenStack for those purposes. But usually you only just get up to the virtualization layer. So you have an orchestrator for starting and stopping virtual machines, and that's it. So somebody said that building private clouds are like summer houses, and public clouds are a hotel. And I think it's a very good analogy, because simply you with a private cloud, usually you're only just making the provisioning of virtual machines easier for you. You still have to buy the equipment, which doesn't free you from the capex of doing that. You still have to hire the people, run the data centers, and all of that. All of that stuff that you get rid of by using a public cloud. But usually you lose the ability, for example, to control the account information and such in public cloud. So there's a give and take there. But definitely building a cloud at scale is very, very resource intensive, both human resources wise and in cost. However, I think NRENs really need clouds, or have a great potential for using clouds. First of all, NRENs have a demanding customer base. Research institutes, universities, students even, that need to be exposed to the latest technologies and to be competitive in the workplace. And also just simply to reduce the cost of running your IT operations as much as you can. You have the existing trust and the federated login support that's already way better than what the industry has, and cannot reconcile in between themselves how to create that kind of federation. And in terms of selling the services, the NRENs are already creating and selling services internally, so that would be easy for them as well. And I think the biggest plus the NRENs have is the networking capability and the experience there, which is, I would say, exceeds probably that of the public cloud creators. And all of the fun stuff you get to do with experimentations and such, something that the private companies can't really afford to do. But you really have a great opportunity as well to influence your users to use sustainable technology. And overall, I think you're very used to merging or integrating existing solutions to create a better bottom line, or even to make things more sustainable. So NRENs in public compute clouds. Why should you use public compute clouds? Well, it's available now. You don't have to build it, really. There's no upfront commitment. It's so easy to try. If you value your time, referencing that, like, it took us 2 or 3 years with a lot of money to get to this place, and a lot of time, a lot of people. But you need to really look for a good cloud partner that's willing to do something specifically for NRENs. And I would say that public compute clouds probably work for 90% of the applications that you need. But maybe creating a hybrid cloud is the best solution. So putting up your own small private cloud, using software to enable that to burst into public compute clouds would make sense. So, like I said before, when choosing a public compute cloud provider, you really need to be aware of the dragons. And the dragons here are, for example, cloud providers that are simply virtual machine wranglers. The first telltale is that they don't have an API, or their API is non-standard. But you also have to think about that today's clouds have both shown that they lack in the protection of your privacy. Amazon, Rackspace, Dropbox, all of them, for example, have complied with the Patriot Act, even in Europe, to hand over information to the US government. And on top of that, they're running an unsustainable operation. I mean, there are better players than some in this area. For example, Google is using around, I think it was around 40%, between 30 and 40% renewables, which is great. But they could do a lot better. And I think that academia really should pave the way to sustainable IT, because the reports on climate change are coming from this community, and then to act in a different way than to fight climate change is kind of a weird situation, I think. So, so what are we doing, or what can we do? Being a startup, we are pretty much open to any sort of collaboration. And we've been doing some fun stuff with SURFnet, and we'll be doing a lot of testing and collaboration with them, and hopefully more NRENs. But in general, I mean, we are the world's first public compute cloud that's truly green. One of the innovative things we've done with SURFnet is that we can connect the NRENs directly into GreenQloud, and they've created a, you can ask them about that, but they've created a path through the education networks to actually reduce or eliminate the bandwidth costs related to public clouds. So we don't charge the bandwidth for the academia into GreenQloud. And so you can bring your own bandwidth to lower the costs even further. And one of the things that we think is evolutionary or revolutionary about our concept is that it doesn't have a green price premium. So we're actually competing with Amazon in prices, and the big players all the time being truly green and sustainable. So another thing that's actually the same luxury you have as the telcos have is that by creating your own network path into the cloud, you could really create an end-to-end service level agreement with your customers by combining your SLA with our SLA. And that's pretty much something that you cannot do over the public internet. Now, we have multiple infrastructure services, and there's a lot more coming, really. So I think we could do a lot of great things together in the coming future. But I just want to leave you now with the last slide with a thought about, can this really make a difference? And I just want to show you like a real world example for the hypothetical situation. And I don't know how many of you know what Apache Hadoop is. Right, so for those of you who don't know, Apache Hadoop is an open source project originally created within Google, right? Yahoo, all right? And it's used a lot today for processing huge chunks of data. And public compute clouds have made it really cheap to do that. So you have, on one hand, a huge problem, which is that data is growing exponentially. And my first slides show that it's basically going from, it's projected to go from roughly 1 zettabyte to 35 in the next 8 years. And since it's growing exponentially, you can see that this is completely unsustainable with current technology and the current energy we have, the current energy composition we have, I mean. So here's a real-world example. It said that by 2017, that Hadoop may process and store 50% of all data worldwide. So Hadoop processing is not a latency-sensitive process. It means it can run anywhere. And for me, that means that there's a huge opportunity there in the near future to actually do 50% of processing for the world's data in a sustainable way. And possibly that means that instead of having a 4% carbon footprint in the next 8 years from IT, maybe we'll have 3. So this is stuff that I got from a company that's a really interesting company called Mastodon C, which are combining the economics of cloud computing and the carbon savings of different public compute clouds. So their lecture was called Saving the World with Hadoop. And I think we can actually do better than that. We can do it for all types of processing and data simply by running it in a sustainable cloud. Thank you.
Thank you for that. We have time for questions. Any questions from the audience? Go ahead.
Two questions, if I may. One is a question about you saying you're truly green. When will the hardware in your data center be made at places that are powered by fire?
Yeah. So that was like the first question I got when we started GreenQloud is that, well, you're not making the equipment. So the only thing we can do about that now, before we're big enough to make our own equipment, is to buy it from a sustainable supplier. So we buy our gear from a green certified or sustainably certified supplier in the UK. But really that's the issue with the vendors. Like, when will they start producing it in a renewable way as well? But all in all, the efficiency definitely is getting better and better with the gear. And the biggest footprint is coming from the operations side and not from the manufacturing.
And the technology question was, when is IPv6 going to be available?
Yeah, so that's one of the projects we have with the NRENs. It's going to be. We're working on it.
Okay, one more question.
it's quite the same question that the previous. You never mentioned energy costs and raw material usage for building new servers, new storage, and so on and so on, and recycling old server, old storage, and so on. Absolutely. It's a very important part of our ACV life cycle.
Yes, absolutely. And that's the reason why we are getting ISO 14001 certified for energy or environmental management. So we take, that's part of what we call truly green, using this sustainable energy, being energy or environmental management certified, and being completely transparent about all our operations, and then showing the users the same kind of thing for their virtual operations. So yeah, we do that. And we even created a metric that's called Green Power Usage Effectiveness, or GPUE, that takes into account the life cycle emissions of energy sources, and we use that to weigh the power usage effectiveness of the data centers to actually show the carbon emissions from any type of data center and their energy mix per usable kilowatt hour. And if you'd like to read more about that, you can go to our website and read our blog about GPUE.
I think we need to proceed. Let's thank the speaker again. So we'll actually be talking a little bit more about GreenQloud in the next presentation. It's my great pleasure to introduce Paul Deckers. He's a technical product manager at SURFnet. Let me see if I can find his presentation here. Let's see. Go ahead.
Thank you. Well, good morning. My name is Paul Deckers. I work for SURFnet. Maybe before I start telling you about the infrastructure cloud things that we do, a little bit about this picture. Our default slide deck actually had a beautiful bridge here somewhere in the US. I thought, well, I can do better than that. We're in Iceland. It's a beautiful place. There must be some Icelandic picture that matches this. Well, this was one of the bridges that I found from a picture I took. I don't know if you know this place. It's the Reykjanes Peninsula nearby. It's a bridge over the continents. You're taller, right? So it's a bridge over the continents. One side is the Eurasian plate and the other one is the American. And you can walk over this bridge and go from one plate to the other. So the fun fact is they do go away a bit. It's like they're dividing 2 centimeters a year, I believe. That's not the link that I wanted to make, but the missing link maybe is, well, there is a bridge, and we were building bridges to put stuff closer together, the NREN and the AIS. So what is it really that we did at SURFnet? First of all, we started talking with our institutions. What is it you're looking for? So we built a task force cloud with people from SURFnet, from our institutions, investigated the cloud landscape, and we're looking at how can we build something, or how can we have something that fits within our community. So we were basically really looking for a community cloud. I will go to the definition of a community cloud later. I think there are many definitions of cloud. So if you look at the cloud landscape, there are various vendors, various operators that you can use. And what does your use case match best? So we do have experience with our own infrastructure. We can share that experience, of course, with our institutions in best practices. We have experience with public cloud providers, so that's all valuable information. But how can we actually glue these public cloud providers that are out there to our community and make it fit? Also, we understood that some institutions were expecting to phase out their own data centers, well, maybe in the next decade or so. I'm not sure if that's really true. It might slim down a bit, but let's say they do, and then they at least need some advice, or we as a community need to look at how you can use public cloud providers for these kind of purposes. This is a slide from Microsoft. I think it's a nice slide that shows the differences in the cloud spectrum. On one side, you have the software as a service, like Gmail, like Facebook, maybe. You don't control anything. You don't control the application. All is controlled by a vendor. So if you want to build your own applications, you could do it on a platform as a service, maybe Google App Engine. But if you really want to run any kind of application that you have and have more control over it, and this actually fits more towards the traditional IT that all of the institutions do, then you can look into infrastructure as a service. There you don't have to worry about the hardware, you don't have to worry about storage or servers or failures or whatever. You just manage the operating system and everything that's running on top of it. So that's very convenient and it saves a lot of time, and it might actually make you get rid of your data center. So the first things that we wanted to do is set up some pilots, see what fits for a community, try infrastructure as a service, try several use cases to see if it really works for us. And we could do that with SURFnet provided hardware, with SURFnet provided infrastructure as a service. This is something I think that many of the NRENs do. They just set up a shared cluster and they hand out resources to their community. But we could also try to find a commercial provider that is willing to connect to our infrastructure, connect to the research networks and make it easier for the researchers to use, or for anyone within the research network, basically. It definitely has to be a secure place, otherwise we won't use it. You have to consider the legal implications, or you have to consider it in either case, or you have to tell your users, or go to a safe place. And one of the other movements is, of course, that we want to have green IT, and this is something that more and more people are asking from us. It was actually in a study that the institutions not just want us to be green, but they also like us to be involved with the institutions and help them to become green as well. So what is it really if we're looking at a community cloud? Well, basically, you have this public cloud that you can use, you have your private cloud on campus, and you can make it hybrid. You can use resources from both, maybe run stuff in the public cloud if your own cloud is not sufficient, if it doesn't have enough capacity. But, so what is really the community part of this? Well, if you make an external part more suitable for your users, more optimal to use, that's probably something that is tied to your community. So within our community, we first of all see that there's huge demand for infrastructure services. And we think that it should be nice if it was easier to use these kind of services. So ease of use is very important. And, well, how can we make it easier to use an infrastructure if you don't really need to do any of the provisioning part? So you already have some kind of federated logon, an account within your institution. Why not recycle this to log into an infrastructure cloud provider? Eventually, we might even use Moonshot. So you start up a VM, and you can log in with your federated account into this VM right away. That would be very cool. That's definitely something that happens within our community, and I don't really think that this is taking off outside the research community just yet. Vendor lock-in is, of course, important. You should be able to get your stuff out. Cost reduction is important. You could do that with procurement. You can have combined agreements as a community with a cloud provider that makes it a lot easier to actually use cloud resources. If SURF already had a good deal, a good SLA, a good agreement with a cloud provider, it makes it a lot easier for universities to just use it. Legal aspects, I will get back to that. Integration with a network. We all have a great network. But it's the cloud network that we often don't control, the one that Amazon has, for instance. So how can we bring these closer together? We are having good deals for our traffic prices. And because this is going outside our network, we would be charged big amounts. And it's better to have a direct connection then. So there's various use cases. In the Netherlands, in particular, many institutions were looking at redundancy and disaster recovery, and many were actually building a second data center on campus or pairing with other institutions to have a second data center. Basically because of this. In 2002, this really scared a lot of our institutions. There was a burn at a fire at one of the universities, and well, this was really their primary data center. There was no backup at the time. We saw the traffic drop tremendously on the SURFnet links. I believe the last syslog messages were, it is a bit too hot here. And yeah, this is still a hot topic, because how do we ensure that the continuity of our services is ensured? Well, basically, people do that by building a second data center that is running all the time. So you have an active situation. Why not make sure that you have your data available somewhere in the cloud and you can start up everything that you need as a backup situation? So you can use public cloud resources for this and have a shared environment that is much more efficient than building your own second data center. So disaster recovery or continuity is one of the use cases that public clouds are really suitable for. So in our pilots, we actually tried, well, we all have these resources, we all have our private clouds or virtualization environments. Can't we just reuse the resources that we already have and share it, in particular with these continuity cases? But it seemed that there was little commitment to actually use each other's capacity, because yeah, then you have these legal issues and you have to give SLAs to your other institutions. That's something to consider. It's still not really taking off that well. But there's other pilots that we did, just with a central VMware vCloud Director platform in Amsterdam, in the Netherlands, in the SURFnet network. We basically did that because every institution runs VMware. So if this really integrates well within their infrastructure, that could be a big plus. The other thing is that we tried to use the platform from GreenQloud that you've just heard about and see how that works for our users. We did that both in the Netherlands. GreenQloud was kind enough to set up a test instance in the Netherlands so we can actually experiment there inside our network. But we also wanted to have this outside our network. That should be the primary use case. So have this commercial cloud connect to the research network. There we have a much better focus, of course, on green computing. And it has different use cases or characteristics than we have in our other clouds. And well, for us as a network business, it's really interesting to see the inter-domain networking and the latency aspects of the applications that we run in the public cloud. Can we, for instance, still do virtual desktops when they run in Iceland? Is the latency then affecting our applications? Well, when creating this slide, I immediately recognized that there's far too much text on it. And I think that's actually a rather interesting thing. I was going over the use cases that we found that worked inside this cloud. I'm not even sure I have all of them, because it's so extremely easy to use these resources in the cloud that we have with GreenQloud. People at SURFnet are just starting up machines without any account provisioning, and they have it running in a couple of minutes. Really, if you don't even have an account, you just log into the portal and you have it, well, running in 2 or 3 minutes, a Windows or Linux machine. And that's the beauty of it, I think. And that's why it's used so much. So first of all, we tried testing with failover for websites. The Dutch Royal Library did that. They had a data center migration, so they ran from Iceland, and we had a load balancer set up that did something in DNS to check whether they were available or not and redirected traffic to Iceland when they were not. This was a bit of a primitive website that they had running while they were not available, but we're doing this with the University of Groningen too, and they will actually replicate their data to Iceland, replicate their databases and their website to have a fully running node here and see how that works for them. They think it's really important that even if all of Groningen burns down, that they're still available for Chinese students so they can subscribe to their studies. For instance, well, the other thing is that we try to integrate virtual machines in the cloud in Iceland or with virtual machines that were running inside a campus. So because of this networking that we have, we can make layer 2 connections from the Netherlands to Iceland via the Netherlight and NordGNet connections that we have. So we also saw that people were integrating this in their curriculum. I found that really interesting. People intend to give VMs to 160 computer science students. Well, then you do have to consider how am I going to deprovision this? How am I going to ensure that they have some kind of quotas and stuff like that? Well, it was used a lot in particular within SURFnet because it's that easy. We did optic fiber network modeling, DNS traffic analysis, mail scanning, unhosted, secure texting, file sender, even ADFS testing. I'm not even sure I have all of them. We didn't announce this as a service even within SURFnet. People just heard of it and said, oh, can I use it? Yeah, okay. So that's how it spread. This is one of the things that got integrated in the curriculum. This is actually running in GreenQloud, and students have this as their final report, the results running inside a virtual machine. I think that's rather interesting. So the role that we have as SURF, we're not sure about. We don't see ourselves offering these kind of services by ourselves, but we can have cloud providers and sit between the cloud providers and the institutions using them. And we could actually help the institutions use the resources in the cloud by defining some metrics, like do you want it to be in the Netherlands? Do you want it to be green? Do you think it's important that the latency is low, or do you want high compute? And that way you can direct your users to the best cloud available. To make it easier to use these clouds, we thought the first step is really to get SAML integration with our federations. And if we have this, this is not just for SURFnet. This will be for the entire educational community because we all do SAML. And the beauty is that, well, GreenQloud is connected through SAML, and we can just log into it and have a machine very quickly. We want to get the SAML stuff also available in open source, so people could actually run it on their own instances of CloudStack. We eventually want to use groups, so you can make teams within your institution, work together, even in international teams. And I think that's really something that is hot inside our community, but not really anywhere outside the research networks just yet. We also have this SurfConnect portal. I'm not sure if you know about it, but it is maybe a kind of brokering platform as a service kind of thing, where you can, well, just like iGoogle, where you can add widgets, and you could add a widget for GreenQloud and starting resources there, or having another cloud, or maybe storage. And that integrates with all the other services that you can get in there, like the weather forecast or your Gmail. So the fact that you can use existing tools, the Amazon API is somewhat the de facto standard, we found rather important. So GreenQloud is compatible with that, and that was a plus, of course. So what we achieved with GreenQloud is that you have on their login page now the login via educational account link. And if you click there, you can actually do the SAML login and get started right away without signing up. So all of the processes, we heard that there were institutions in the Netherlands that researchers actually grabbed their credit cards because that was a faster way of getting virtual machines than going to their IT department. Yeah, that's a bit of a pity, because the IT department has no overview, no control, and they couldn't even tell how many users there were. Some think there were none, but we know there were. And it is much better if you can aggregate this and have some overview and more controlled billing and better deals if it gets bigger or not. Well, this is an example of the demo portal. GreenQloud made a gadget as a widget within this portal. It's similar to what you can get with iGoogle. And with this simple interface, you can actually start a machine just the same as with the friendly portal that GreenQloud itself has. So the network integration we did via Netherlight and NordGNet. here we're using really the strength that we have as a research network. And we're using the strength of Iceland and GreenQloud to have compute that is green and efficient. And we can still start machines behind the institution firewall or use the NREN IP space and reduce the networking costs here. And this is very interesting for us to just see how it works with latency. This is a graph from Equinix. It wasn't really educational, but I thought virtual learning environments would actually fit rather well in the 100 millisecond range. I often take Facebook as an example. Facebook, for a long time, was only running in the US. There were users all over the globe, and we didn't really feel a pain of high latency. It just worked. So you can optimize your applications to make it work well, even over long distances. So we actually hope that virtual desktops would work well, but that's definitely something we want to test. That's a challenge. In regard to green IT, we really noticed that, well, you can have efficiency in cloud services. It would be efficient if you, as an NREN or whatever, aggregate the resources within your community. And maybe you should, to give users a choice. You go either this direction or that direction. That's the brokerage model. But it's not just about the efficiency and building these nice containers. This is the Amazon Perdex that is showing the containers that Amazon makes. And the pay-per-use stimulus is, of course, also a stimulus to make it more efficient, because you're paying for the resources you use. So if you shut it off, this machine, then you're not paying anymore. That's definitely a stimulus to be more efficient. But to be truly green, you need to consider the power sources that your grid has. Not just the power that you buy, but also the power that your local grid has. This is a table from Wikipedia that shows the amount of CO2 per kilowatt hour. Well, if you look closely, you see that wind is 2 times in this list. That's because of offshore and onshore wind, before I get that question. And even wind and all the geothermal and bio stuff is also giving some carbon emissions because of the life cycle of these power plants. Someone has to build this wind mill and has to build a hydro dam or thermal solar PVs. So GreenQloud's focus on green is not just the energy source. They report on it very well, and they do have a very green energy source. Well, actually, they have 100% renewable energy, and that's the only place in Europe and, well, maybe in the world where you actually have it like that. I think this was the table that you were referring to that's on your blog, but I included it anyway. This shows that you have the PUE of data centers, which is important, that it is low and efficient. In Iceland, it is low because you can just open the doors and have free cooling. The humidity aside. But even Google and Apple and Microsoft have good PUEs in their data centers, and we're building PUE data centers in the Netherlands with 1.07, I believe. So we can do really well there. But it's the energy mix that is used by the data centers that is really bad. In the Netherlands, the best we can do is like 13% renewable energy in our grid. And it doesn't really matter if you buy 100% renewable energy because it's not in the grid. And that's the mix you have to consider that you're getting. It would be good if you could actually shut off one of these coal plants instead of building a new one. So there you can use other countries' strengths. In the Netherlands, we really have to put energy into water. We have to get energy to machines pumping the water out of our grounds, because otherwise we get wet feet. Other countries get energy from water. This is the Oliden power plant in Sweden, which I think it was the first in Sweden. So also Sweden is a much better place for data centers in that regard than the Netherlands is. For us, it's only cost energy. Well, this is the proportion renewable energy in Europe. It surprised to me actually that Austria was a runner-up to Iceland. Iceland is really 100% green. Austria, because of the hydro, probably is 62%, and Sweden is the next 54%. In the north of Sweden, there's an abundance of energy, I think, and you could build data centers there very well. Facebook is doing that. In the south, there's less abundance, there's more nuclear there, and there's no real power lines between it. So the question is really, am I moving the power or am I moving the bits? You could just get the power from the north of Sweden to the south, which apparently is already hard. It must be a lot harder to get it from Iceland to, well, for instance, the UK, which is closest. I find it a bit of a ridiculous plan. Someone really has to explain it to me why that works well. Because fiber doesn't have the power losses that the energy cables have. So getting a fiber to Iceland is much more efficient. Getting a fiber to the north of Sweden is much more efficient than the power losses that you have. Even in the very efficient cabling. We have a very efficient cable, I think, running from the Netherlands to Norway, where we import a large part of our renewable energy. So if you look at the data center risk assessment, it's even interesting. Apparently, the Netherlands isn't doing that well. We're on position 14. The US is 1, of course. It's a US study. So for political risks and stuff like that, the US is scoring really well. But Iceland is 4, and that's basically because they have cheap energy, good cooling, and a lot of water, which is also important for data centers. In the Netherlands, we already need a lot of water. We do have water, but it is a bit of a pity to vaporize precious drinking water into the air for cooling your data centers. So that's definitely something to consider. Political stability, education, water, bandwidth. So yeah, in the previous presentation, this was shown as well. GreenQloud reports on your energy usage. I think that's important, and I hope this sets an example for other cloud providers. As we have with the SAML integration and stuff like that. The other thing is the legal aspects. You have to consider where you put your data. Well, Iceland is inside the European Economic Area. And this is important for Dutch law, at least, that your data stays inside. You can go outside with the data, but it's rather soon, data is rather soon personal data. And then you have to tell your users that your data is stored someplace else. That's the risk you have with US suppliers. And you don't really know what they do with your data. They might disconnect you from this data, and that's a risk that you don't have in these kind of countries. So what we really see is getting federated access to the clouds is really lowering the barrier for usage. We hope that this is all setting an example for other infrastructure providers, for institutions, and for other research networks. And we think this is just the start. There's a lot to be done. We still have the group support. We have the IPv6 that Alan just asked about. That's definitely something that's going on within our community, and that not all of the infrastructure providers are considering. But, well, GreenQloud is one of the more innovative infrastructure providers, I think the most, because they were willing to work on this. And it would be great if others just follow these examples. And yeah, I'm also wondering where our data centers are in the next decade or coming years. I really don't know. And I know this question is there for the users. And even if you still have your data center, you can consider, well, do I need to have all my lab work there? I really want to have something easy to access. Good. I think that was it. And I hope there's time for questions.
Yeah, there's a little bit of time for questions. Let's thank the speaker. Questions?
Could also be about the puffins or
yeah, you can ask about puffins.
the bridge. It's nice puffins.
Any questions? No. So you're collaborating a lot with GreenQloud, but how specific? You said that you're very general in your interfaces and so forth, but have you really tried it with any of the other ones? Like, have you interoperated with some of the bigger players and so forth? And what about not infrastructure as a service clouds and so forth?
Yeah, okay. So we were basically focusing on infrastructure as a service because of the other things already going on with Google and a platform as a service. We think that that area is relatively covered already by the work done in other groups. Mm-hmm. as far as the other cloud providers, we really noticed that we tried to talk with Rackspace and get them convinced to work on these kind of things and Amazon. Maybe if they're watching the stream, I get an email tomorrow. That would be great. But they were really not that enthusiastic just yet to build these kind of things, which I think is a pity, because if we have a demonstrator now that really shows the power of it.
Right, exactly. And maybe a follow-up question from that. How do you see clouds evolving in Europe? Like, do you think NRENs are going to play a key part here to enable it? Or do you think it's going to be small, fragmented clouds that are going to collude? Or
no, I definitely think that NRENs have a big role there. Also to advise people and give information about it. But also to connect the users. We have a lot of users in our community doing research, doing studies. If we can make it easy for them to access these resources that they need anyway, otherwise they would probably spend their money on compute machines to do local compute, and it will get dust eventually. So that's a pity, and this is a much better way of dealing with these resources.
Great.
Yeah.
We have a question from the audience.
You said you followed a bring your own bandwidth approach to GreenQloud.
Yeah.
How about scalability? So if another NREN would like to follow the example, would they have to bring their own bandwidth as well, or could we join you in your efforts in a way?
Well, maybe not. Maybe we can collaborate there too. I mean, part of this link is provided by NordGnet and via Netherlight, and people can actually connect to any of the optical exchanges, like there's now in London via NordGnet. And I think optical exchanges might really be a key role here if you want to connect your own networks to these locations. And these links are there, and they're not fully used yet, and otherwise there should be more capacity. And at least these links are using less energy than your server is percentage-wise in your own country. So yeah, I don't think there's a scalability problem just yet. And maybe if it is, then that's a nice challenge for us being networking people.
Great. Final question from the audience? No, let's thank the speaker again. Thank you. So we were traveling south a little bit here. So we saw Iceland, and we're moving down to SURFnet in Holland, and now it's time for Spain. It's my pleasure to introduce Jordi Guijano, or something. Guijano, there you go. Sorry for butchering your name, and you would do that. So he's operations and security manager at Cesca in Catalonia, and he's going to talk about the Spanish RNE Cloud Initiative, if I can find this presentation. Here you go. Thank you.
Good morning. Thanks for coming. This 25 minutes will explain what's the mission of Mega. First of all, I want to introduce myself. I'm Jordi Guijarro, and I work from Cesca. It's a public consortium that provides ICT services to the research and education community in Catalonia. It also manages the research and education network that name's called Nella Científica, and coordinates with NRENs, Rediris, and to make some initiatives and to make participate in some work groups. Let's see. This is an image. We have a zooming of two images that we can identify as the similar material. By one side, we have a cloud. We have a cumulus cloud. You have a persistent cloud, and you have steam on the other side. Mega, our main objective is to identify a similar vapor cloud. You know, as a similar concept that is vaporware. We want to help to our constituency, to our community, to identify what it's or not vapor cloud. And what cloud computing really means. It's a strategy, it's a statistical solution, and maybe it's just a buzzword. We can identify now types of clouds, features, modes. We can compare to grid computing. We can compare with, we can identify benefits, the locality, and so on. But what we are talking about. And for the end user, we think that the battle it's won by global providers. They have in a model that our citizens' data it's in the cloud. And what's for our community? What's for our institution? What's the risk to make cloud-ready services? Now, I want to repeat the last presentations, but we can identify the three layers and the new roles that are used in these layers. And at the end, what is the value of the visibility of the end user? I want to represent this inverted pyramid that represents that we are in the way to make sustainable infrastructure. But what is the implication about the concept? Infrastructure as a service provides services to platform and software as a service. And we can identify how it is used in a self-service. This is the word that I can introduce that a new paradigm and that cloud computing really means. If you consider that we were talking about responsibilities and we enter in the infrastructure as a service model, we have a clear objective is to avoid to maintain infrastructure. Infrastructure may be a large cost for our community, and we have to solve this. We have now an opportunity to make things well done. As a cloud provider, we, SESCA, and so on, provides infrastructure as a service and on each layer. And the main word is sustainability. It's the thing that we can gain. And mega working group, what's this? We want to investigate about the opportunities of a really true cloud computing paradigm. And let's pull all together. Our mission is to promote the development of innovation in cloud computing technologies within the scope of the institution affiliated to RENS, and to act as a catalyst for application of the development of new application in this world. It's a new world. As highlight words, I want to make some cases that we are, besides an open standards, we can identify, or we want to identify user cases. We have built a testbed to check the capabilities, to check the different things that we have to be done to make cloud-ready services. The promotion of this kind of features in a true manner, and about identity, a word that represents a lot of things. Our main objectives, the first of all, is deploy a federated cloud infrastructure as a platform for innovation and evolution to our constituency. The second, we want to explore the possibilities for the application of cloud computing as in the research, academic, and also in management environments. At the end, facilitate the creation of ecosystem of software that is produced by our communities as a clients, as a middleware that can provide solutions. And we are talking about an evolution. We can detect different trends that we have to be aware. One of our purposes is to accelerate the infrastructure as a service change. And this slide, we have no title because it's the manner that we have done things last years. We are putting all the eggs in the same data center, in the same infrastructure, and the risk, and it has a risk, a real risk. If you can identify some phases of the trends that can represent the evolution of our infrastructures, we have in the first 3 and 4 phases. We have in the present, we can have private clouds where you're offering our services and public clouds, and you can determine how and what can you use for some purposes. In this phase 3, we have new virtual private cloud that is in a hybrid scenario that we can switch where we provide the services. And the last, and alternative of the federations, we have the new concept, the new paradigm is intercloud, the true intercloud, and 25 is benefits. Which is Wikipedia, it's intercloud, have a definition. It's intercloud is interconnected global cloud of clouds, an extension of the internet network of networks, which it is based. We can make a extrapolation of the well-known internet. And the Mega Intercloud project. The Mega Intercloud project, we can pass from the myth to the reality to be a testbed. We have here Spain. In Spain, you know, you have some autonomous communities that provide and have some capabilities of governance. And in an initial stage, we can identify some clouds, some centers that are providing cloud infrastructure as a service in the present. They're providing to scientific and academic communities to provide services. About a high bandwidth provided by Redis Nova. And about interoperability, it's a word. We have to make a new virtual POC. We need different pieces. We need several pieces to accomplish a true interop between clouds. And I want to present OCCI, you know, Open Cloud Computing Interface, promoted by an Open Grid Forum. And it's an open interface that helps to make easily the provision of infrastructure. Networks, private networks, storage, and instance. You can upload storage, etc. But we have this OC client that will be identified by a user or a director or an inline process. It's important. We can integrate and need to integrate that several processes that need infrastructure as a service can talk this kind of standards. And to make it interoperable, the next stage that we have done, like this map, this diagram, is to provide OCCI in each of the clouds, to provide and to make the first phase, that is compatibility. Next stage is federation. Now we have solved that we can interact with some clouds to make a provision, the provision tasks. But which is the identity here? We can use PKI Grid as a PKI, national PKI for science in Spain with certificates arrive to this new API. Now we have an infrastructure. We are using OpenNebula as an amazing framework to offer infrastructure as a services in 3 geographical dispersed instances with about 300 distributed cores, some storage, network security, and support. And what is that we can do with this? We can manage images, we can manage instances, networks on each of the clouds with the same identity and with the same compatibility. We provide on Redis Nova and Scientific and so on, provide high-speed connectivity to access to these services to our community. We have provided SSH access to the resources, and another thing that we have done, we have user manuals, we have generated service provider how-tos to add new service providers, and it's important therefore service of this testbed. This testbed is to check, not in production. We want to make things to discover the true requirements of our service, of our community. The main players here, we have the 3 infrastructure providers. We are powering cloud power identity and connectivity and software, and we provide the most important, as the user. The user can provide what are the requirements to make things. Here we can see the Open University of Catalonia, Autonomous University of Barcelona, a tier 1 LXC, of the LXC project, a PIC, Port d'Informació Científica, and so on. And here's, I think, maybe the interesting part of the presentation is some real-world user cases. As the natural users, we are building services from community to the community. The first stage can identify as a user case the Learning Apps project. The Learning Apps project is to build a store on the internet inspired by Apple App Store which focus on educational applications. It's the main objective of this is the provision of the on-demand educational environment and in an automated manner. We are using OCCI. It's the only API that we are offering in our testbed. And the amount of infrastructure that it needs, it's on demand and depends on inline parameters such as preconfiguring concurrency. They need a RESTful API, they need automation, they need service on demand, it's education focused and need contextualizations to make all run. Why? Well, there is some ideas outside the infrastructure that needs this automation. We are talking about the learning tools interoperability, LTI, that promote and implies to make a on-demand deployment of the infrastructure. It's a requisite that we have to solve. Here is a screenshot of a real case. The user can choose the learning application that want to deploy. If you can choose, as an instance, WordPress like that, you can define which is the concurrency for this product, and automatically, when you pay, you have a new provision infrastructure to provide these services. Another, we're talking about read and cloud. They are complementary, they are different things, they are similar. We think that they're complements. If we can see a read that have a lot of years running and offering service in the scientific community, we see that there's interware that are managing resources. In this case, DIRAC, it's a community-grade solution that allows an homogeneous access to heterogeneous computing resources. And it manages read resources, cloud resources, and physical resources. And this objective is provide transparent access and interoperability between grids and clouds with OCCI 1.1. It's the last release. And this is in current work. We have highlights, keywords, interware, DIRAC. We need integration is for scientific purposes. And this schema diagram, they can identify the different components and where is in this thing, the mega cloud or the testbed. We can identify that at the end, we are interacting with an interware, the user interacts with the same interware, and this interware has the capability to integrate with some providers to some resources. We are talking that we can see as the same thing. In a virtual machine provision, we can identify that it's DIRAC who through his director, inbox an image, interacts with a RESTful API, and with the framework that provides infrastructure services, arrives to public service, distributed public services. We have here an intelligence that covers this feature. At the end, the virtual machines that are running in the cloud, geographical dispersed, with public connectivity, arrive to direct to report what are the jobs, where are the jobs. If we are talking about an academic application, we can identify a user case of the University of Barcelona with his extension of his BDI platform in a hybrid cloud. With the friend here, we want to extend his UBDF platform inside public services. The main objective was to extend this private university UBDI platform with public cloud resources in a hybrid cloud scenario. Hybrid cloud, transparent, point-to-point, own images, contextualizations. We can see here the network scheme of the connectivity, and we can identify his virtual machine networks, the public virtual machine of the provider, and this point-to-point connection. This is one of the things we have to solve. That is, if we want to extend networks, avoiding administrative processes that in a research education network may be more easily, we have to provide some components as VPN, multipoint, point-to-point connections to make that when a user arrives to the portal as a transparent for they choose which the desktop that he want to use to make the lab and so on, and arrives to a public resource. Network is one of the strategic things that we have to think about to solve this problem. It appears big LAN, etc., and so on. We have to think about it. And the last, you have Sergei, the supercomputing center of Galicia, and his cloud access services. He's offering cloud access services and supercomputing services as usual. At the end, the user invokes on-demand isolated clusters in a self-service mode. And why cloud here? Because this service needs isolation, needs flexibility, needs accounting, and root access. And it not be shared with the typical supercomputing cluster. It's the lab, researchers that make samples, and at the end arrive to cloud provider. Here is Cesca. And some conclusions here. This is only the tip of the iceberg. We are talking about infrastructure as a services. The last layers, the battle is lost. What's the next steps for our mega cloud? One of the main activities that we have focused is the compatibility and features. This is augmented by our constituency. We need firewalling, we need extension of private networks, and so on. The second main was to build a marketplace that to provide some instances and to have an only place to store them. And at the end, as a SURFnet reflections, we want to construct a brokering model, where is the accounting, etc. At the end is this last slide, where the future community for the cloud model and what can we provide. We know that we provide scalability, with commercial providers included, that we expect that includes OCCI in his timeline. We have a distributed exchange by nature. We have resource sharing, high availability, and at the end, an efficient use of infrastructure. Gracias. We can make a strategy, and thanks for your attention and for your patience.
We have time for a few questions. Is this from the audience? Yep.
The breakfast.
Yeah. It's fine.
Hello, Yuri Demchenko, University of Amsterdam. Do you have a kind of technical concept of intercloud or federated cloud architecture models?
We're talking about a new model, and we're trying to investigate what is about the intercloud. We're talking about to transparent transfer services from one private cloud for another. We are talking about only to make to easily make a federation of identity to arrive the provision APIs. I think that is a large concept that a lot of research projects are making things about his definition, and it's only that with the tools that we have now, about in the perspective of service providers, is how it's the approach we can arrive at this with this orientation.
I don't want to use for advertise, but still I want to mention, if you come during the break to the poster number 2, you can talk about technical concepts.
I know it. I know it.
More questions? Yes, there's a question from the front here.
Yeah, very interesting project. I've seen similar things happening in the commercial world with companies like Enstratus, RightScale, Scalar, that are doing public or private cloud to public cloud and creating this sort of thing. And I think it's an important field to pioneer as well in the education space. Have you talked to any of the public cloud providers in participating in something like this? I wasn't clear about that in the slides. And what is their uptake for OCCI as an API? Because, yeah, maybe it's best for you answer that, because I have a feeling that not a lot of them are supporting that today.
About OCCI, we think that this has a future. We have years at the last release 1.1. It's covering PAS capabilities, and we know that there is a lot of work to be done, and commercial providers with things as EC2 that runs, and it's de facto standard now. You have to make a hybrid or to build the same umbrella to cover at the end of requirements that are of our constituency.
Maybe a follow-up question is that it's great to have standards in this space, specifically for compute, and now we also have an emerging standard for storage, which is DC. Yeah, CDMI. Sorry. Very few vendors have started to support that as well. But have you envisioned that you're gonna have a problem when you start working with the public cloud vendors because they have different networking models? Like Amazon has a very different networking model than other providers. Yeah,
we are in a test bed that promotion. We are offering free infrastructure for our community. Who is our community who is supporting here? It's to adapt OCCI. This is that we are providing infrastructure, we are providing that with an emergent standard, and with these projects, such learning apps and that, are using EC2 too.
Okay.
And they include the possibility to use OCCI platforms. And we open and we help the standard in academic environments to adapt it, not only for commercial purposes.
Yeah.
And now appears a new layer, software layer, that can aggregate all these standards to provide, GClouds, and so on.
Let's thank the speaker again. Okay. We're out of time, so thank you for attending the cloud infrastructure section, and please provide some feedback on both the conference and also this session. The break starts now. Thank you.